Hello and welcome to Technical Utkranti, and today we'll learn how to find median using heap from a continuous data stream, which means that data comes to us repeatedly, and after consumption of each data we need to return the median. Alright, so let's move on and let's have a look at the thought for the day. So these are the topics that we have covered till now, and we are still left with covering all these topics. So let's get started. And under heap we have done these many questions, and today we'll be looking at the median finder question. So we are continuously receiving data over here, and after reception of each data we need to find the median. But let's have a quick look at what median is. Alright, so median is a central tendency. Alright, what is central tendency? Central tendency is like whatever data set that you have, what is the central meaning or central value for that data, that from which you will get some idea about the data. So we know there is something called mean, median and mode, right? So mean is what? It is just sum all the data and divide with the number of data points. So with this you get some idea about the central tendency of the data. What is median? Median is to arrange the data from like in ascending or descending order and then finding the middle point. This also gives some idea about the central tendency of the data. And what is mode? Mode is to find the element which occurs most number of times in the data. So all these are the various ways to find the central tendency of the data. Here we are seeing how to find the median. So in order to find the median, let's suppose we have the numbers like 1, 3, 8, 9, 10 and 12, right? So these are even numbers, even number of numbers, right? And what we do is we arrange them in ascending or descending order, which we have already done for now, and we'll find what are the middle numbers. So these two are the middle numbers and their average would be the median of the data set, right? So now let's have a look how are we going to find the median using heap. So we'll use two heaps, max heap and min heap. So let's suppose the first number we receive is 10, and we to begin with, when both the heaps are empty, we put the number in the max heap. Alright, and the median is also initialized to 10 when all the heaps were empty and when we put the first number. Okay, now let's suppose the next number that comes up is 3. So if 3 is less than the current median, if 3 is less than the current median, it goes to the max heap. So it comes over here, right? Now we see what are the number of elements. Number of elements are even, but min heap and max heap are disbalanced, right? So we expect that when the number of elements are even, the min heap and the max heap count should be the same. If that is not the case, we'll pull the topmost element of max heap and put it in the min heap. So there remains 3 and here comes 10. And then we take the topmost element of both the heaps and find their average, and that becomes the median. Alright, now next number comes out to be 12. Now 12 is greater than the current median, so it goes to the min heap and resides here. Alright, okay, so when the number of elements are odd, then if the length of min heap is greater than max heap, then topmost element of min heap becomes the median, and otherwise if max heap length is greater than min heap, when total number of elements are odd, then topmost element of max heap becomes the median. So in this case 10 becomes the median again, right? Alright, now the next number that comes up is 8. Now 8 is less than the current median, so it goes to the max heap, and we know that max heap, the top biggest element goes at top, so this gets arranged like this, right? Now we see that the number of elements are even and both the max heap and mini heap are balanced. So the average of the top two elements of the heap becomes the median, which is 9. So our median is 9 right now, right? Now the next element, let's say we get from the data stream, is 9. Now 9 is the same as the median, so we just put it in the max heap and it becomes 983, and the number of elements are odd, so the top and the max heap length is bigger than min heap, so 9 becomes the median, so 9 stays to be the median. And let's suppose the next number we get is 1, right? So when we get 1, we see that it is less than the current median, it goes to the max heap, right? 1. And now the number of elements are even, but min heap and max heap are not balanced, so we take the element from max heap, all right, because it has more elements, and put it into the min heap, so it becomes like this, and this becomes 9, 10, 12, and we take the average of the two and we get the median. So I hope you understood what the algorithm is. Now let's have a look at the code to understand the algorithm in a much better way. How are we going to calculate? So we'll be receiving a number recursively, and we'll see. So we have initialized a data set like this. What this data set has, it has a max heap, it has a min heap, it has a size of the max heap, size of the min heap, an indicator whether the first element is inserted or not, and the median of the data set. Okay, so when the number is inserted, it first of all sees whether or not this is the first insertion to the data set or not. So if it is the first insertion to the data set, then this remains equals to 0. We put the number into the max heap. So both our heaps are basically the min heap, but in order to take a heap or consider the heap as max heap, we insert the negative of the number into it, and when we take the number out of the max heap, we do the negative of it. So in that way the normal heap acts as a max heap. Okay, now and we basically say that the topmost element for the first insertion is the median. We increment the size of the max heap and declare that the first element is inserted. Okay, so for the first insertion, median is sorted. Now the second insertion comes, it comes to the else part. Now here what happens? Here it sees whether the number is greater than the median. If the number is greater than the median, then it goes to the min heap. Okay, if the number is smaller than the median, it goes to the max heap, and we increment the size of min heap and max heap respectively. Then we find total number of elements in both the heap. If total number of elements are odd, then what happens? So whenever the total number of elements are odd, we expect that the max size is just 1 greater than the min size. Alright, if that is not the case, we reduce the number of element from the min heap by 1, put it to the max heap, and then we find the topmost element of the max heap. Right, so this you can say is a corner case. Otherwise, if total number of elements are even, then if max size is not equal to min size, as we have seen in the example on the whiteboard, we extract the element out of the max heap, put it into the min heap, and then we extract the top two elements of max heap and min heap and find their average and declare it as a median. So this is the algorithm. Let's see if our algorithm runs fine. Yes, it does. So I hope you liked the video. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.